Okay, what we're dealing with, we'll be dealing with the 5% rule, and there's a little example of it, but basically what you want is when you have large amounts of something that you're testing, but you only sample a very small amount. In this particular problem, they had 247 million some odd, and they only sampled 3. Well, 3 is going to definitely be less than 5%, and as long as it's less than 5%, you just pretend like they are independent events, that the outcome of the first has no effect on the outcome of the second, even though technically it would have a little bit. Okay, let's look at our actual problem. It says among 8,601 cases of heart pacemaker malfunction, 436 were found to be caused by firmware, which is a software program into the device. If the firmware is tested in 3 different pacemakers randomly selected from this batch, 8,601, and the entire batch is accepted if there's no failures, what is the probability that the firmware for the entire batch will be accepted? Is this procedure likely to result in the entire batch being accepted? Okay, well, your total number they gave you was 8,601. They say 436 were defective. 436. So those that are not defective would be the difference in those two. Take the total and subtract the defective to get the non-defective. And those should all add up to be the same. Well, the probability, let's do this way first. The probability of getting one that's not defective, what would that be? We would take that number and divide it by the total. The non-defective divided by the total. That's the probability of 1. Now, the probability of 3 not defective is going to be the probability of 1 actually cubed. So, we want to say equals sum of this number right here, and we want to raise that to the 3rd power. Okay, now this is our probability that we're going to answer with, and that's 0.85, and that would round to a 6. So the procedure is likely to result. That's relatively high. It's likely to result, and the whole thing being accepted.